I have changed things a little bit. Hopefully you'll enjoy the change. We are only going to be doing homework up to part B. And so the last section of section 6, we'll push that on to the following week, right? We've got a little bit of flexibility, so I'm doing that. So we're going to be looking at normal curves, essentially yesterday's stuff. Going to do examples using salt, which makes life really easy, right? Makes it easy to do. And once that's done, I'll spend the last part of today talking about your midterm, just reminding you all the good stuff. Okay, so essentially what we've got here is what's called the normal distribution, right? So you collect data from a population, and very often a lot of data has this kind of symmetric look to it. And we're going to look at questions that talk about finding the probability, which is essentially the same thing as finding the area, right? What fraction of the data would be in this side, or what fraction would be between two values? There are only 3 basic questions: bigger than, less than, or between, right? And they're all going to be done with salt. So in the first story, the mean of this population is 34. Mu is 34. The standard deviation sigma is 9. And so if you wanted to draw what that thing would look like, basically 34 right in the center. And then it's the questions are phrased in terms of, at least a lot of them, in terms of the word probability. So they say, what's the probability that a value selected at random from this distribution will be greater than 34? So if you imagine this as being the distribution, there's the mean right at 34. Greater than 34 is everything to the right. And this one, I don't even need to use salt. Would you agree that 0.5 either side, right? The whole thing is 100%, but as a decimal, the whole thing is 1. And so that probability that you get greater than 34 would simply be a half. Now, in your midterm exam, this question here could easily be in WebAssign. Couldn't you just have, put in the decimal and call it good? I could also do it in the second half of your midterm, where I just gave you the question and you would essentially write down 0.5. So here's an example of one of those situations where salt becomes more useful. Suppose you have a mean of 6, a standard deviation of 2, and you want to find the probability that you pick a number somewhere in the region 5 to 8, right? So all I need to do is use salt to find out what this area is, and that will be the same as the probability. So the area under a curve is equivalent to the probability of that particular combination of numbers happening. Right. So I'll nip over, and we'll do in a few moments. There we go. There's the buttons that we're going to press. Right, so you click on use salt and this appears. Now, in the question that I was doing a few moments ago, you turn the mean into 6 and you turn the standard deviation into 2. And we want to know a between. So I think between's pretty easy because it says between. Then you go over here and you put between, what was it, 5 and 8. So bigger than 5 and less than 8 is how you would do that. 8. And the answer is that number there. So I could copy that number. And there's my answer. Now, round your answer to 4 decimal places means a little bit of a tweak. And submit answer. And am I good or am I good? Right, it's great. So in this question, wouldn't you do very similar, but this time the mean would be 15.2 and the standard deviation was be 14.3, and then wouldn't you do bigger than 10 and less than 26, and you get the answer that would go there. Right. And there's one where you do 7 to 9. Let's do this one. The mean is 22. The standard deviation is 3.4. And we want to know what's the probability that you pick a person at random and it's greater than 30. So if you wanted a story with us, imagine that you had a class where the average age was 22 and that the standard deviation was 3.4. What's the chances that you pick somebody from that class and they're older than 30? Right? So if you wanted a story attached to that calculation, that would do it, right? So you go over to solve. The mean is 22. And the standard deviation was, I believe, 3.4. And what was it we wanted? Greater than or equal to 30. Okay, there's your choices. If you want to do a greater than, which of those left, right, both, or between? What do you do? If you want greater than 30.
Right?
Correct. If you want less than 30, which one do you do? Less than 30. That's what I was interested in. Which one of those would I pick?
Okay.
Okay. Less than, left than. Remember yesterday, L and L, less than, left, more than, right, and the between. Now we want more than. Maybe I should shrink this a little bit. That may help. Right, so we want more than 30. And the answer that we came up with is very small. So the chances that that happens in this particular one, and to 4 decimal places, would be that guy. Oops. 22, 4.2. Let's check I did it right. Ah, 4.2. I can leave everything else the same. Make that 32. There we go. So check it this time. Okay, what's wrong with this question? 22, 4.2.
You said less than 32. It's supposed to be 30.
I didn't. Did I?
Yeah.
If I had a brain, I'd be dangerous. Okay. Third time's a charm. Aren't we lucky that you get 5 shots? At last, right. If I had write down, if I used the right numbers, wouldn't have been able to write down the right answer. I mean, it's not a hard thing to do. Right. And now we get the same basic job, but they put it in the form of a story. So here's the story we're going to do. I'm going to make this big so I can read it because it's, a lot of words and so on. A person has a blood glucose level and diabetes are closely related. Okay. So when you get tested, they very often do your glucose, don't they? And if it's high, they might look into maybe you're pre-diabetic, for instance, right? For instance. Now let X be a random variable measured in millimeters of glucose per deciliter. And suppose that after you've had 12 hours without eating, this variable will have a distribution that has a mean, so I'm writing that down so I won't screw it up, of 88 and a standard deviation of 25. Okay, and it says a little note here, Note after 50 years of age, both the mean and standard deviation tend to increase. And for adults under 50, after a 12-hour fast. Okay, so we have to find the probability of an adult under 50, essentially, using those numbers. Anybody who does the medical thing, is 88 a kind of middle of the road number for a glucose level after a fast?
Yeah.
Sounds about right? Okay.
Yeah.
So we want to know then, what's the probability that you, let's say it's you that they tested, have a level that's more than 60? Right. So the mean is 88, the standard deviation is 25. What's the chances that you get one that's more than 60? That should be quite high, I would think. So you go here. I'm going to do that, shrink it back again. Oh, darn it, I can't do both at the time. Okay, I'm keeping it big. So the mean is 88. And over here, the standard deviation is 25. And we're trying to find what's the chances that they have a glucose level greater than 60. And if you kind of look at the picture, would you agree that's a pretty big chunk of space? And that ends up being that fella there. So I'll copy it and I'll place it in here. And it's a typical 4 decimal place answer. So what's that, about 86.86% chance, which is pretty much a large majority of people that would be true for. And there we go. Now let's jump to this one. Greater than 125, which according to them is borderline diabetes, right? So if you get a glucose level and it kicks into the, the high 120s, your doctor's going to be a little bit interested in you as far as diabetes goes. So let's see what percentage of the population that would actually be. So greater than 125. Now, can you see that's this chunk of people over here, right? Greater than 125. And that ends up being almost 7%. Wow. But as a decimal point, 0.069 is almost 7%. That's quite high. So what that means is for under 50, about 7% of Americans are pre-diabetic, right? They're either diabetic or they're darn close to becoming it. Again, does that sound about right for the people who know these things? Well, what's 7%?
Yeah.
That's, yeah. So that's about 1 in 14, right? 1 in every 14 people have got a possibility of having diabetes. Yeah. I'll share with you. I have got so many things wrong with me that it's, if I was a horse, they'd shoot me by now. And yeah, I got all sorts of readings that my doctor keeps telling me I should be getting less. But I don't know. I'm too stupid to listen. Okay, I've got some, just get it in my head because it's in my head. I have all sorts of cool things wrong with me. I have a genetic disease called polycystic kidney disease that I've been told will eventually kill me. But since I've got a very slow version of it, I'll probably die of something else before it kills me. So I chalk that off my list of, I'm not going to worry about it. Then I had a brain tumor, which was kind of fun. I had a brain tumor that was called a, what was the damn thing called now? Pituitary gland tumor. So right at the front of your brain, there's a tiny little thing that dangles like that. That's your pituitary gland. And I had a tumor on it, and it was knocking me blind, which is how they found out I had it. And I got the operation, and the surgeon, my neurosurgeon, was saying, if I had got it 20 years ago, I probably would have been dead, because the success rate for that operation was horrible. they used to cut the top of your head off, pop up the thing, and get into your brain that way. And that's thankfully not how they did it with me. They just stick holes in your nose, and they go in, and they go into this little thing, and a little camera and a little gizmo thing, and it basically shreds it and sucks it through. And that one's gone, so that never got me. God, I've got a list of 10 other things that will kill me. And I got to the point in life where I figured out I'm going to die of something. So why should I bloody worry about which one of the 10 things that could kill me is going to be the one that's getting me? Because you know Murphy's Law, whatever I eventually do die of, it probably won't even be one of those. When I get run over by a bus when I'm not looking, something stupid will kill me. So that's kind of how I look at life now. I don't worry about it. If I'm going to drop dead, at least I'm going to have fun before then, which is why I love Vegas, amongst other things. So let's return back after sharing stuff I'm sure you didn't want to know about. Let's go back and look at another question. I think it's all this medical stuff that's getting to me. Yeah. Right. I'm going to murder some of these words. So those in the medical side of the word can have a good laugh. But here's my version of this. Properin. Am I even close? Zach, you're laughing. That was horrible, was it? How would you pronounce? No, you're good. Okay. Properin is a pigment in blood, protoplasm, and other bodily fluids that is significant in body energy and storage. Ah, so that's the stuff that flows through your blood that your blood can suck up and burn to, so that we can move. Let X be a random variable, represents the number of milligrams of this stuff in your blood. In healthy circles, it's approximately normal. So this stuff has a mean of 40 and a sigma of 13. And we are then being asked, what's the probability then that you have less than 16, more than 16, between 16 and 60, and then that one? I think I'm going to do these two. Let's do what percentage of people, right? What's the chance that your level is in this range here? So 40, 13, and they want 16 to 60. Right. So for this propylene stuff, the typical mean value is 40, and that the standard deviation is 13. And we want to know a between. So I'll pick the between choice. And that means it has to be greater than 16. And it's going to be less than 60. A pretty big chunk of space. And the answer is that. So the chances that a person has a level of propylene between 16 and 60 is that number there, that decimal there. So let's copy it, put it in there. Probably 4 decimal places. Yes, it is. So let's just check that, make sure I didn't screw up. Cool. Now, if X is more than 60, this may indicate an infection or anemia. Oh, I didn't expect that. I should have read it before I did it. Anybody want to tell me why that is the case? Why would a high level of this stuff mean that you might have an infection, for instance? What's your body doing?
It's trying to fight the infection.
Oh, so this stuff has got
So
lots
your
of
white
uses.
blood cells go into like overdrive to try and fight the infection.
Right. So if they are getting made, you need the fuel to help them.
Yeah.
Okay. So what's the chances then that this is true? So greater than 60, greater than 60 is quite high. So copy that and paste it into 4 decimal places. that gets rounded up, so 20 should be the answer. Let's submit it. There we go. Now, they say that there are other things. So anemia, is anemia lack of blood? I know I've heard of anemia, but I'm not quite sure what it is. Is it lack of red blood cells in your blood, or is it physical, the volume of blood that you've got is less?
I think that it just references lack of something in blood.
Okay.
It's a lack of red blood.
Right, so you don't have the red blood cell. I mean, the volume's the same, but there's just, it's like your blood is watered down. Would that be a non-medical way of thinking about it? Right, and or other illnesses. Right. Okay, that makes sense. I don't win that one. It was pretty boring. Oh, let's do this one. It's a little bit different. Question 10. The resting heart rate for an adult horse should be 51 beats per minute. Somebody somewhere get paid money to find that out. Go figure. Now, horses range from 27, okay, which is obviously the smallest, up to 75. Okay, got that. And let X be a random variable that represents the resting heart rate for any particular adult horse, and assume that everything is normally distributed. Now they've got a nice little description here of something that they are telling us, and then we're going to use this piece of information. So one of the things the empirical rule tells us that is for symmetric, bell-shaped, the other 8 names we've got for it, approximately 95% of the data lies within 2 standard deviations of the mean. We know that, right? 1 is 68, 2 is 95, 3 is 99.7. So that means that the interval is the mean take away 2 standard deviations up to the mean plus. So if you take whatever number that is and you measure it up to whatever that number is, do you agree that that distance, that length, is 4 sigmas? Does that make sense? If you start and you go 2 left and you go 2 right, you end up with 4 sigmas. This leads to this rule of thumb, right? It's a very basic rule, but it kind of works. That you can approximate the standard deviation. Do you see those 2 little squiggly lines that look like the OC symbol? That in mathematics doesn't mean it's exactly equal to it, but that it's roughly equal to it, right? Approximately equal to it. And they say that the standard deviation is approximately the range divided by 4. And the range is the high value take away the low value. Okay, now back to this story then. Since that guy is 27, that's the low number, and that guy is 75, I should be able to just subtract those 2, that's the range, and divide by 4, and I now have an estimate for the standard deviation. We go with that? So 75 the biggest, take away 27 the smallest, divided by 4 gives me 12. So use this rule of thumb to estimate the standard deviation. I'm putting in 12. Are we good? Right. Now, the mean is 51. The standard deviation, or at least the estimate for it, is 12. Once you know those 2 numbers, you can start doing all these guys, right? Right, what's the probability that the heart rate is bigger than this, less than that, or between 2 numbers? So let's do this one. The heart rate is greater than 60. So I go into salt, and I put in the new mean for the horses at 51. And for the horses, the standard deviation is 12. And I should go check what I want. And we want greater than 60. So right tail greater than 60. And the answer comes out about 22% roughly. and rounding off to 4 decimal places, we'd get that. Now, this is a new question that we haven't done before. A horse whose resting heart rate is in the upper 7% of the population, right? So, have a secondary, okay. A horse whose resting heart rate is in the upper 7% of the probability distribution of heart rates may have a secondary infection or illness that needs to be treated. So in other words, if you test your horse's heart rate and it's quite high, right? The top 7%, right, is pretty high. That's an indication that your horse is ill in some way, right? What is the heart rate that corresponds to this 7% cutoff point? So you can actually do that from salt. You know how it's on the right tail? And that's this bit, okay? Now the mean is 51 and the standard deviation is 12. Normally, don't we put numbers in here and this is the answer? Let's turn that on its head. We are told that this number, oops, too many zeros, is 0.7. And that means this is the heart rate you would need to be in the top 7%. Does that make sense? And so, copy that. Now, what do they want? Nearest whole number, okay? So, that rounds up to 69. So evidently, if you're a vet, or at least a vet that specializes in horses, you would have as a rule of thumb, check the heartbeat. If it's 69 or more, that's a bit in the high side. You know, maybe I should check things. Does that make sense? So you can actually use this in 2 different ways. The most normal way to do it is, what's the probability? It's bigger than this number, less than this number, or between 2 numbers. But you can actually turn it on its head. Let me use this fella for an IQ test. Typical IQ test has a mean of 100 and a standard deviation of 10. And I would like to know what IQ I need to be in the top 1%, right? The Einsteins of this world, the top 1%. Well, all I do is I change that to 1%. And do you see that you would need an IQ of 100? Whoops. Do you see it? 123 roughly. So if you take your IQ and you end up being 129, you can be really kind of chuffed, you know what that word is, right? Pleased with yourself and say, hey, I'm at least in the top 1%. Now, you can also go the other way. You could take American football players, and we all know that they're pretty dumb, right? Because they hit their head off things all the time. And I wonder what the IQ of let's say the bottom 5% is. So if you want to be in the bottom 5% of IQs, won't you have an IQ of about 83, 84, roughly, if you round it off? Now, if you want to do this as a medical thing, right? Let's suppose you're measuring some blood level. I'm making this up, but the average is 25 and the standard deviation is 2.2, right? Oops, not that number, 2.2. Now, when you have a kind of average and then a standard deviation, isn't there a little bit of wiggle room, right? As long as you're in this middle range, you're okay. But if you're bigger than this, that's a bad thing. And if you're less than this number, but we'd like to know what those cutoff points are, right? And when I get my blood tests, they always tell me things like, you know, this is the number for whatever it is, your potassium, your calcium, whatever it is. And then it will say, you know, normal range, but want to also say high or low, for instance, or extremely high and extremely low. Let's see how they calculate those guys. So for this made up blood chemical, 25 is the mean and the standard deviation is 2.2. I would like to know what is a dangerously low level. And so I'm going to make a judgment call. if you're in the bottom 1%, would you agree that's probably a dangerous place to be, right? So all you do is you make that guy 1%, and you're on the left tail, you see it? And so you would probably do something like, if your level is less than 20, you have an extremely low potassium level, right? If this is what it measures. Now, you want to know the high one? Easy done. Pick in the right tail. And let's say you want to be in the top 1%. There you go. So you could say a level of 30 is too high. So once you know the mean and standard deviation of any normal body chemistry, right? This enzyme, that glucose level, right? This blood pressure, that weight rate, whatever it is, you can always find the mean and standard deviation. I mean, all you need to do is collect lots of people, right? Typical people, right? Average them out, you know, plug it into a computer, get the standard deviation. That's the only two numbers that matter. Once you got those two, can't you do these kind of questions like what is too high and what is too low and what is normal? And a lot of the things that you get in the medical world were done using this technique. Now, I don't know what the too high is. Maybe the top 10% is considered too high, right? Or maybe it's the top 1%, or maybe it's somewhere between those. But isn't there a value for each of those that you can do? And if you've got kids, if you go to the doctor and your kid is, say, 3 years old, don't they have charts that say for a 3-year-old boy, this is the normal kind of weight range, this is the normal height range? And they will tell you, yep, your kid's bang on where he should be for a 3-year-old, or hey, you've got a basketball player here, he's kind of tall. And that's not a bad thing. Or maybe he's not developing quickly, right? Maybe he's a little bit smaller than that age group. Now that can be done for a lot of reasons. Couldn't it just be genetics, right? Some people are small. But it could be a growth hormone deficiency, couldn't it also? So at least your doctor would know to use that information, hopefully in a wise way. Here's basically the same question, but it's to do with kittens. Well, I guess vets need to know what's good and what's bad for a kitten. All right, let's look at 12 now. Attendance at a large exhibition show in Denver averages 7,800 people a day. Okay, that's a good number. And has a standard deviation of 525. So about almost 8,000 people on average every day, but it varies from day to day. And the variation measured by the standard deviation is about 500. And there's the clay, everything's normal. So what's the probability that you get fewer than this number? What's the probability you get between this number? And lastly, what's this number here? Let me do a different version of that question. Let's suppose that in this large exhibition show, you only have enough room for 850 people. Or sorry, 8,500, right? That's this, you know how the fire people say you can only have so many in a restaurant, right? Conventions can only have so many people in a hall, right? So let's say it's 8,500. Let's find out the probability that the thing's going to be full, right? In other words, anybody else that's coming, you're going to say, sorry, you can't get in today, we're full. So that means that standard deviation, and we want to know what's the probability that you're actually going to have more than 8,500. So you, oops, I don't need to click on that, but I've got it now. The mean is 7,800. The standard deviation is 525, and we want greater than 8,500. And I'll copy this. And the answer, I've just put the answer down here. Although that's not where it belongs. Right. Can you see that if I round that off, isn't there a 9% chance that you're going to have a full audience, right? A full convention. Right. Now, if that convention was over, say, 10 days, right? It's a big, long convention. That would mean one of those 10 days, it would end up being an overflow, right? Roughly, right? 10% of the time, 0.9. And that might be okay. So I'm now going to do another one like that. And this time I'm going to make it up. But if you've ever done enough flying, this may well have happened to you. Let's say that there's an aircraft and its capacity is 190 people, right? Not a huge aircraft, but it's an aircraft. And the mean number of people who book a flight is 175, and the standard deviation is 11. What's the probability that your flight is overbooked? In other words, more people buy tickets for that particular flight than there are seats for you. You ever been in the, I mean, me and my wife, as you know, we were in Vegas, and I, being Scottish and like saving money, was quite interested in doing it, but my wife wasn't, because the guy got on the speaker and says, this flight is overbooked. Will you, if anyone wants to volunteer, we'll give you, a free, a flight tomorrow, and whatever it is, $200, that kind of thing, and they give you a hotel room. You ever experienced that in airports? Maybe you were the person that can't get on the flight, which isn't fun at all. But flights do that, or airlines do that, because you think it's strange, but a lot of people, relatively speaking, a lot of people don't turn up for flights, right? They catch a later flight, right? They don't come in time, or especially business people. If you're a business people and you're not paying for the ticket, it's dead easy to, no, I'm not going to that conference, I have to go somewhere else, and you just cancel, or you just don't turn up. So that's why they do it. Let's find the chances then you're overbooked. Well, that would be the probability that X, the number of people, is greater than, say, 175. And I just said the wrong number there. Going to be greater than 190, because that's the capacity. So I'm going to nip over here, and we are going to see what the chances of this particular flight being overbooked are. Are you looking at a salt button? Can you see the salt? Okay. So in this case, we're talking about an average of 175, and the standard deviation is 11. And we want to find what's the probability that it's greater than 190. And the answer comes out about that number there. So roughly an 8% chance. Okay, let's talk a little bit about consequences. For this particular flight, let's say it's a flight to Vegas, right? It's an 8 a.m. flight to Vegas, right? And that particular flight tends to have 175 people on it, but it does have variation, right? Some days there's a lot more, some days there's some less. There's an 8% chance that that flight is going to be overbooked, right? So roughly in 12 of those flights, one of them is going to be overbooked, right? The other 11, there's going to be enough room, right? 8% is roughly 1 in 12, right? Why do airlines do this? Why do they take more people tickets than the plane can hold. What's in it for them?
That way they don't lose out on, on the airfare and they can charge them any more tickets.
Well, you know, you want to sell every ticket, don't you? And if you know that normally you lose 3 or 4% who just never turn up, you're still getting the money for them, aren't you? If you fly a plane and you always make sure that there's 2 or 3 spare seats, isn't that 2 or 3 spare seats, right? So you never book more than, you know, the capacity of the plane. Aren't you going to lose money in the sense that you're not going to sell tickets for those extra 2 or 3 seats for safety? So it's cheaper for them to, in 1 in 12 flights, to have an overbooking. And then they have to make deals like, I'll give you the plane, you know, the next plane at 9 o'clock, and, you know, give you $100 if it's a big inconvenience, like, well, you'll have to come back tomorrow. Well, I'll give you a hotel room and $500, you know, whatever it should be. It's worth it to them because of all the other times where they managed to get a full plane or almost a full plane and get all the money for it. So it's a risk analysis that they've taken, which helps them. It doesn't help you. God forbid I ever have to do this, but see if I have to go on a cruise with my wife and I know the cruise is today, the last thing I want to hear from the airline is, sorry, we overbooked, you can't get on the flight. Would you agree that would not be a good idea? And I'm not sure what how I could sue them. I'm not sure how I would be able to do anything about it. I would threaten to sue them, hoping that that would maybe get them to say, does anybody want to give up their seat? This couple are wanting to go on a cruise and whatever, who knows? I just think it's kind of weird. I guess that's what my brain is saying. You were in Albania, weren't you, Sinclair? Did you fly over? Well, that's
Yes.
stupid. Of course you did. It's where it is. Did you have a cruise once you flew over? That's more important.
No, we just rented a car and drove down kind of by the border where Greece is, Athens, that island, and then we were right across from Corfu, down there on those islands in between.
I am so jealous. I've been that part of the world. I've been to Athens. Athens is a big disappointment to me. I went to the Parthenon and that was fine. But Athens as the city, you know, where everyone lives, was
Yeah.
very unimpressive.
Yeah, it's just a tourist trap.
I know. It's a bit. Rome is beautiful. And if you've only one place in the world that you're going to visit, guys, my opinion, go to Venice. I know it's a tourist trap, but forget it. It's such a beautiful place. I love Venice. I would go today. And now you've distracted me, or I've distracted me. Let's get back to what they pay me for. Right. Question 13 is really just a duplicate of 14. Let's see what this one is about. The amount of money spent weekly on cleaning and maintenance repairs in a restaurant was observed over a long period. And so this is weekly. So that's $627 was the average. And the standard deviation was 37. Okay, so I've got the two numbers that I need. If $646 is budgeted for next week, what's the probability that the actual cost will exceed this? So aren't they really saying, what's the chances that it's bigger than that number, essentially, right? So what's the chances that you end up having to spend more than 646? So I'll click into that one. I'll put in the mean, which is 627. I'll change the standard deviation to 37. I'm already set up more than, and I want to know more than 646. And the answer to that question is big, relatively speaking. What did they want? 4 places? Oh, I guess I shouldn't have changed that. There's your answer. What's that? About 30% of the time. So would you agree that that restaurant's not really financing maintenance? Because 30% of the time they're going to be short, right? And they're going to have to, get some money from somewhere because they haven't planned for it. Now, how much, it's a different question now, how much should be budgeted so that the probability that it will be exceeded is only 0.14? So they're willing to accept 14% of the time I didn't put out enough money. They're not willing to accept that number. Okay, so it's all set up. The only difference is I make this guy 14. And that comes out to be about that number there, which I'm sure we're going to round off. So if they budget to the nearest dollar, let's see what that rounds off to. So that's about 667. So if you want to be at least safe, except 14% of the time, as long as you put in your budget 667, you'll be able to do all the usual repairs most of the time. And then 14% of the time, you'll be underfunded. 14 because of that number. 15, I think that's, yeah, it is our last question now. Police response time to an emergency call is different between the time the call is the difference, of course, between when they get the call, right, and when the car knocks on the door, right? So over a long period of time in a certain place, the response time has been calculated as a mean of 6.8 minutes. Well, if there's a maniac breaking into my house with an axe, 6.8 minutes won't do me much good. And the standard deviation is 1.9 minutes. Suppose that you randomly looked at an emergency call and question A wants to know what percentage is between 3 and 8 minutes. I got the whole thing set up here. The average time is 6.8. The standard deviation is 1.9. And we want to know a between one. I haven't done one in for a while. Between. So it has to be bigger than 3 minutes and less than 8 minutes. And there's your answer there. So the chances that they will arrive somewhere between 3 and 8 minutes is about 0.71 of the times. And what do they want? 4 decimal places. So in this particular city or town, about 70% of the time they'll arrive in that range. Okay. Couldn't we do greater than 3, less than 3, I should say, or more than 10? I'm going to do my own one. I wonder what percentage of the time they will get here in 10 minutes or less. So less than 10 minutes. So left tail, less than 10 minutes. And that comes out at about what? 95% of the time. So in this place, if you phoned, you've got a serious emergency, you can be sure that 95% of the time they'll take less than 10 minutes to get to you. Of course, if you turn that on its head, doesn't that mean 5% of the time it'll take more than 10 minutes to get to? So, yeah. I don't have a gun. I've got one good eye. I've never touched a gun in my life. I've never held one. They scare the EBGBs out of me because I've seen them. So I'm in trouble. If a maniac with an axe is smashing into my house and I live in that place, I'm going to have a problem. So that didn't cheer me up one bit at all. Okay, so I'll finish with a joke and then we'll start talking about our midterm. So I need something. Well, Scottish humour is kind of macabre, so why don't I just tell you a Scottish joke? So, sad story this. Whiskey distillery in Scotland. There was a Scotsman and two Englishmen that were working on some scaffolding round the big vat of whiskey. And the scaffolding collapsed and the two Englishmen and the Scotsman fell in. And the Scotsman died and the Englishman lived. So the manager of the distillery phones up his wife and says, look, you'll have to come in. There's been a terrible accident. Your husband get killed in an accident. So she comes in and she says, well, what happened? And says, well, they were on the scaffolding and they fell in and the Englishman, they swam to the end and they got out and they lived. And your husband, he died. She went and said, oh, I hope at least his death was quick. How long did it take? And he said, it took 6 hours. She said, it took him 6 hours to die? I said, yeah. It would have been quicker, but he climbed out twice to go to the bathroom. No. Zach, come on. Are you with that joke, or that joke is just so bad it's not worth laughing at? What's going on here?
It's so bad it's hilarious.
Okay. Yeah.
It's good though. It's funny.
Yeah, I'm a great believer in bad jokes, as you already know. Okay. So let's just give you a quick refresh on your midterm that's coming up. I'll put this, I think, under student view. Here we go. So you should be looking at our module. I'll just shrink it up a minute. Midterm exam 1, right? Our exam is going to last 3 hours, right? Now, our exam is a little bit more complicated than you might want, but essentially it's going to be broken into 2 parts. There's going to be 15 questions in the website, right? So it'll just be like a homework, online exam, right? It's going to appear, i.e. you'll be able to start doing it exactly at 10 o'clock. So when you go into website, and that's what I suggest you do first, at 10 o'clock it will appear, and you've got as much time as you want, but remember the test is in 2, so I would say you should really get finished, in about an hour, get that bit over with. And then the other 2 hours, I would suggest that you then spend on the second part of the test. Now, the online part is in WebAssign, right? That's the first part. And we also have in Canvas, or we will have in Canvas, mid-exam part 2, which I should be able to click and it should be blank. Yay. It will be here. When you click on this, there'll be a PDF and you'll get questions. Now, these questions, the part 2, are the ones that require working. So you will write down what the answers are and how you got them and all that good stuff. And then you'll use either, I think Aidan's going to use his printer to turn it into a PDF, or Microsoft Lens, you take pictures of it, or whatever way works for you, but you're going to get it, all your working, in a PDF form, and you're going to be then uploading it to here. So once you've done the exam, you'll click here and you'll go start assignment, upload file, choose file, choose whatever you've called it, open it, and lastly, submit. Okay, so you don't need to show me working for the WebAssign part of the the midterm, right? It's just like normal homework, right? I don't see that homework working either, right? You just put in the answers. The WebAssign questions are going to be, for the most part, are going to be things that you would use SALT for. You know, the questions today would be a classic example of that, right? Where you just went in, whatever the answer is, type it in the box and call it good, right? I'll also use the WebAssign for, do you know those questions where they give you a story and then there's 4 dots or 5 dots and you have to pick some, here's something, is it 1, 2, 3, 4, that kind of question. So if you're wondering what kind of questions, that's the kind of ones. Do you know the ones that we did, for instance, that if you wanted to do a 5-figure summary or a box plot, couldn't you do those kinds of things on SALT, right? That would be the kind of situations. Now, what would we be using the on-ground, the Canvas version? Well, those questions that there is working that you could show me. For instance, a lot of the probability stuff that we've done, right? The probability trees and the probability of getting a king and an ace, those kind of questions, or rolling 2 dice and getting a total of 7. Those questions would be in Canvas, because isn't there working you could show me there, right? The numbers that you would get, or you would draw a tree diagram. It also could be used, and it will be used for, if I give you a small set of data, shouldn't you be able to use your calculator to tell me a 5-figure summary and draw a little picture of a box plot, right? So for small sets of data, right? For instance, stem and leaf works well with that. I could give you a reasonably small set of data and say make a stem and leaf of it. So questions that look like that would be on the second part. And for instance, in a stem and leaf, there won't be any real working, but won't drawing the stem and leaf be the working, right? In other words, I'll see what you're doing when you draw it. Any questions so far? Right. The weighting for the two, so it's 15 and 15, so there's 30 questions altogether. The weighting of the two is not equal. There's only going to be 100 points for the WebAssign questions, because a lot of them isn't it just press a button, write in the number and you're gone, right? There's not a lot to do. So only 100 points will be in those. And the other 200 points, because yours is going to be out of 300, it is going to be on the part 2, right? The fella that you should see here. Yeah.
And part 2 is going to be
2.
right there when we log
Yeah.
into Canvas.
Right. When you come in to Canvas, and you'll be on Zoom, so you'll use, where's that Zoom link? There we are. Right. So you're going to use this Zoom link, not your class one, but this one. When you come in, I'll see you, and you will then start doing your stuff. And basically, it's security, right? I can check that Zach's not using his twin brother or his wife or his 15-year-old son to do any of the questions. Out of those 3, which one would you pick? Would your wife be the best choice, or would you choose your son?
Probably my son.
Okay. So anyway, to make sure there's no cheating, right? Now, once you're finished, right, you've done all the questions as best as you can, and you've uploaded it into Canvas, you've still one last job to do, and that is you check with me, because you're going to say, I'm finished. I will go in and check the upload. I will go in and check WebAssign, and I might go and say to you, hey, you forgot to submit all. None of your answers are there yet. Or if it's Canvas, I will say, you don't have any working for questions 7 or 8. And you're going to say, yeah, I couldn't do those. And I'll say, that's fine. Or you're going to go, oops, I forgot to take pictures of those 2. And you'll go and do it again and upload it. And then I'll say, yep, they're all there. We're good to go. So that's the kind of the last hurdle, right? That I want to check that everything you've done and could do, I've got it, and then you're off. So it shouldn't take you 3 hours, or at least most of you, it won't take 3 hours to do it. And so when you're finished, right? So go and have a coffee or do what you want. You don't need to be here once
Does it
it's
have to
done.
be in a particular order? Like if I wanted to do part 2 first, then go
Do
back to part
any
1?
order you like, don't matter. And if you look at the little thing that should be in front of you right now, the exam finishes at 1, but you're getting a little wiggle room of 30 minutes, and that 30 minutes is because it'll take you time, right, to do pictures and to upload it and maybe fix it because you missed a page and all that. So we're not going to make that a stress thing. So you've got a chunk of time there if you'd really need it, but you know, you shouldn't hopefully need it.
So we have until 1 to finish the test, but we have until 1:30 to upload all our information. Okay.
Exactly. That's it. Okay.
Yeah, that could get a little messy if you haven't done it before.
I got you. Whatever, you know, the tidying off at the end is whatever you need. I think 30 minutes hopefully should be enough. What other things? I think I've answered everything I can think of. You ask me, what have I not done that you'd like to know? Ask me a question.
If we have a question on the test, is it a like wave your hand and then ask it, or like type it in chat? How do you want to handle that?
The easiest way for you to do it so that is, do you know how you do private chat?
Yeah.
Right, so the reason I want you to do it that way is I don't want you to say something like, in question 9, do you mean a placebo test like the person doesn't know what he's getting and the doctor doesn't know what the treatment is? Because if you ask the question like that, haven't you basically answered the question for everybody?
Yeah. Okay.
So if you put it into a thing now, I might be able to say to you clarification, because you might say to me things like, I don't know, I'm trying to think of some. How many decimal places do you want this answer to? Because the question didn't say.
Okay.
Right. And in which case I would say, yeah, I want 2 decimal places, and that would be fine.
Okay.
And you might ask me, it depends on the question. A lot of questions, unfortunately, I'm just going to have to say, can't help you. I'll tell you after the test.
Okay.
And other questions, I you know, if it's a different type of question, I can tell. But
Okay.
that's the best way to do it.
Cool. Thanks.
Any other questions? So we're all good with the time slot, right? 10 till 1. I know, Aidan, we've got a different, right? We're cool. But has anyone else got a problem with that time slot? You know, I have to pick up my kid at 12, right?
I
Because
have
there is a
a-
little bit.
Sorry, my apologies. I have a quick question.
Mhm.
So I don't get off until 2 p.m. Eastern time. So I know we emailed a little bit about it. So do I just like pop in here into the Zoom after I'm off?
When you're ready, you will just join through the same Zoom link everybody else is going to join through. And in your case, I will just adapt things so that you've got the same amount of time to do what you need to do. So you know,
Absolutely. I appreciate that.
Not a biggie. Pretty easy to do.
Wonderful. Thank
Are
you.
we good with
I
that?
appreciate that. Yeah,
Right.
absolutely.
Any other questions? I think we're last name and done then. I'll hang about for any, you know, you might have a question you just want to tell me. Oh, there's something in chat. Oh, that's okay. That's you doing what you should be doing. Right, last name for attendance. And I will, as I say, I'll hang about for anybody who's got an individual question they want to ask. Okay, bye-bye for now. Right, and Zach, if I see your son anywhere near you, I'm going to be really suspicious. Just putting that down as a piece of advice.
All right, make sure to keep them out of sight then.
Yeah, just throw him outside, lock the door, and tell him to come back in 3 hours. You know,
I usually
something
do
like
that anyways in the afternoon, so we're good.
that.
I did
So
have
you
a
won't
quick
notice
question.
anything different. You get a question.
I did have a quick question. I'm having a little bit of problem with the probability rules and trees. Is there like someplace I could go to like help me work through some of those formulas. I went back and I tried to write them down. I even went through the book and it's just not clicking how to use those formulas, like, probability.
Yeah.
Stuff like
My
that.
normal advice there is if you just do a YouTube search like
Yeah.
probability tree
Okay.
and look there, because there's a whole load of resources out there, and sometimes it's just if a person describes it a different way, it'll click. Not everyone thinks the same,
Okay.
and so that might help.
Yeah.
That's
Is there
about the
a,
only.
do we have do we have, since it's a summer class, do we still have the tutors available?
Yeah, they
okay.
do. There are tutors. Contact. What's her first name? Haynes is her last name. I'm trying to remember her first name.
Haynes. Okay, she's a good
Yes.
tutor to look up.
Yeah. Well, she's in charge of tutoring. We also, if you go looking, we have online tutoring because basically, you just log in and ask some questions. You might get some help there as well. So yeah, that would be
And
another
then,
resource.
and you
Nadine,
said
there it is. Nadine Hayes is her full name.
Oh, okay. All right. And then you said that you also upload your last recorded classes on a Canvas too, just so that way I could go back for like reference and stuff. Or I was looking for it yesterday. I didn't know if I seen that. I thought you.
I don't know if I've done that. Let me see if I did that.
Yesterday showed up this morning.
Okay.
Oh, they're good then. Yeah.
Yeah.
Okay.
Okay. Cool.
So
Thanks.
here's another thing you might want to look at since you're here. I'll try and show you. If you click on this one called Video Topics and Lecture Notes, if you click on, for instance,
that's nice.
these guys,
Yeah.
there is some more videos that you may want to do, or PDFs and so on. So you were talking about probabilities, right? For instance.
Yeah. I'm getting my butt kicked in that chapter 4, probability rules and trees. So I figured I would just stop and try to get like some extra help with it.
Right. So here is probability videos.
Okay.
If you click on this one and you click on the expansion, there's a basic probability one, addition rule, the multiplication rule.
Oh, okay, cool. I didn't even see that
So
there.
there's quite a few. Some are me, some are other people, but there's a probability tree. 46 minutes. That's probably a previous class, I would think.